Hello friends, today we are going to derive equations of motion. We'll derive first equation of motion. As you know, first equation of motion we write it as V is equal to U plus AT. The symbols you are well aware of. This is final velocity V, initial velocity U, acceleration A and time is T. Since this is the relation between velocity and time, sometimes it is also referred to as velocity time relation. Okay, so let's derive it graphically. The graph we have to make is between V and T. We will be making the graph between V and T. So our consideration, suppose our consideration is there is a body at point A and it is moving with initial velocity U. U is our initial velocity with which your body is moving. And suppose it accelerates uniformly. It accelerates uniformly means the graph will be a straight line graph. It accelerates uniformly and attains a final velocity V. Okay, at point B, it attains a final velocity V. So this much distance is your V. Okay, so this is our consideration. Now to do some graphical derivation, what we are going to do, we are going to make a perpendicular from B on the time axis. Just make a perpendicular line from B on the time axis and also a horizontal line from A that is parallel to your time axis. A horizontal line from A, let us mark this point by C and this point by D, and this point you can mark it as E. This is just marking the point so that for writing the derivation it becomes easy. Okay, so this much is U, this much is V. Now how to start your derivation? Starting the derivation is very easy. From the graph, what you can see? From the graph, you can see that this BC, if I write this BC is what? This is sum of BD plus DC, right? This is your BC. It's summation of BD and DC. So BC is equal to BD plus DC. Now why do I need this BC, BD, DC? I need UV. So let's substitute wherever we can. This BC, see here, what was your BC? It was final velocity V. What was your BD? Oh, it's a difference between V and U. We don't know what it is. So let's it be as such. What about your DC? Just see this. If I take this DC, this is actually equal to, let the initial point be O. This is actually equal to your AO, which is your initial velocity. Your body started with this much. So U. Right? Now, if you see this V is equal to U, only this part we have to substitute with something. Okay, this BD we don't need. So let this be equation number 1. Okay, so now this BD we need to substitute with something from the graph. We don't want this BD in our equation. So coming back to your graph, see here BD is the vertical distance. Okay, so we already have V, we already have U, only this A is missing and T is missing. So A is the slope of the graph, and you also know it's a VT graph, right? It's a VT graph. So in VT graph, you know, in VT graph, the slope of the graph gives what? Acceleration. In a VT graph, slope of the graph gives acceleration. We have already learned that the slope of a VT graph is equal to acceleration. So that means, what is the slope? What is slope formula? Slope formula is vertical distance divided by horizontal distance. Or if you know tan theta, then tan theta is equal to opposite side by adjacent side. That is slope. If you don't know tan theta, then always slope is vertical distance by horizontal distance. So that is given by acceleration. Acceleration will be equal to vertical distance, which is BD over here, and horizontal distance. Horizontal distance is AD over here. Okay, horizontal distance is AD. in triangle ABD. Now, you also know that from graph, your AD, see here, AD is equal to OC. Okay, AD is equal to OC and that is equal to time taken T. So instead of AD I can put as T. So A is equal to BD by T. By simple arrangement, BD is equal to AT. If you just substitute this value in equation number 1, substituting the value of BD from equation number 2 to equation number 1, your equation number 1 becomes, so we'll write that substituting value of BD from equation number 2 to equation number 1. What will your equation number 1 become? It will become V is equal to, instead of BD what should I write? AT plus U. By simple rearrangement we can write this as, or V is equal to U plus AT. Okay, we have written U first. Okay, so V is equal to U plus AT. So we have derived what? We have derived velocity time relation, or the first equation of motion graphically, which is V is equal to U plus AT.